everyone, this is Sravana working as Assistant Professor in EC Department from Institute of Aeronautical Engineering. Our today's experiment is UJT Relaxation Oscillator. Here we'll check the output waveforms across the emitter as well as base B1 and B2. This is a circuit diagram of UJT Relaxation Oscillator where you can see this is a UJT where unijunction transistor we will call it as. Here we have an emitter terminal. As per you can go for transistor where for transistor you have emitter, base and collector, but for this you have only emitter terminal and other two terminals are base. So here you can say base B1 and this is another terminal base B2. So if you see the circuit diagram, in this UJT relaxation oscillator is a type of an RC resistor capacitor oscillator where the active elements is a UJT, that is nothing but unijunction transistor. A unijunction transistor is an excellent switch with which switching times in order of nanoseconds. It has a negative resistance region in the characteristics and it can be easily employed in relaxation oscillator. So UJT relaxation oscillator is called so because the timing interval is set up by the charging and discharging of the capacitor which is present here, which is connected across the emitter to the ground. So here you can see it is see the output waveform of the UJT relaxation oscillator with the corresponding capacitor voltage and the output. Where you can see here in the circuit diagram, the base B2 is connected to the resistance R2 and resistance R2 other end is connected to the VCC. And you can see here the emitter end point, one end is connected to the resistor which is connected to the VCC and other emitter end is connected to the capacitor which is connected to the ground. So this R1 which is connected to the base is directly connected to the ground. So the capacitor and resistor, both the ends are common connected to the ground. So this is the UJT relaxation circuit connection. And you can see here how to identify the UJT. So UJT also looks like a transistor as we have BC107. This also have three terminals, emitter, base B1 and B2. So if you see the notch here, if you place your notch to the UJT notch to your side, from there you can say anti-clockwise emitter, base B1 and B2. So here if you make it as in the reverse option here, the notch is present. From there you can go for clockwise direction, emitter, base B1 and B2. If you reverse it, it will go for anti-clockwise. So this is the pins representation of the UJT relaxation oscillator. We have emitter, B1 and B2. If you can see here, emitter and base are near. The far one which is placed across these two emitter and base one will be always represented as B2. Now let us check the output waveforms of this relaxation oscillator. So these are the output waveforms where you can see the output across the emitter and the output which is charging and discharging. That is nothing but this emitter is nothing but where capacitor is charged and discharged, and this is the output voltage which is taken across the base to base. That is nothing but B1 and B2. So you have a spikes across the output. So these are the two output waveforms we need to check, where at the capacitor and emitter you have and charging and discharging, that is across the capacitor, and the output across the two base B1 and B2 is taken, that output is a spikes output. So now let us observe this. So let us connect this circuit and we'll check the outputs. So here you can see this is a UJT where the base end is connected to the output, the B1 end, and another B2 end is connected to the output. And here the resistor is connected from the base which is given to the ground, and here another base is connected to the ground. So here you can see these are the this is the ground, and this common is called as VCC, where resistor, you can see here The resistor end is connected to the VCC. So this is a resistor which is connected to VCC, and remaining are grounds. So this resistor and capacitor ends are common grounded, and here we have taken a resistor R1 and another resistor which we are connected directly to the VCC. So this is the VCC end, this is the ground end, and these are the two outputs which we are taken, that is nothing but for B1 and B2. So now let us check the output. Here we are giving VCC as 12 volts. You can check via this 20 volts multimeter. So this is the output. If you see here, because this is the output which is given. This output is across. Here this spikes are nothing but output across the base B1 and B2 which is taken, and this is the output across the emitter end, that is nothing but across the starting end of the capacitor. So depending upon the charging and discharging of the capacitor, the output voltage you are getting as spikes. So this is the final output where you need to go for the calculations are nothing but in order to observe the output waveforms, that is nothing but the voltage across the emitter, and the output, that is nothing but spikes. This is the output of the UJT relaxation oscillator.
Like, share and subscribe. Hit the bell icon for more updates.